Half of the chapter is about congruent figures. This is about similar figures. So what are similar figures? Similar figures are the same size shape, but not necessarily the same size. So this means that we can either shrink them or enlarge them. In order for shapes to be similar, two things have to be true. One, all the angles have to have the equal measurements. And two, all the sides must be proportional. So we're going to use some 7th grade math in here to be able to tell if our sides are proportional. Notice here are two similar shapes. They're not congruent because they're not exactly the same shape. Notice this one's bigger, this one's smaller. Duh, right? So how do we know they're similar? One, all corresponding angles must be congruent. What are corresponding angles? Angles that match up. You'll notice that I have a large angle for 90, a medium angle for 57, and my smallest angle is 33. What's my other triangle? Large angle 90, medium angle 57, and small angle 33. You'll notice that they call these the corresponding angles because these are both the medium angles. Obviously, the 33 and the 33 would also be corresponding angles. Corresponding sides are very similar. You'll notice that the corresponding sides are right here. This is the hypotenuse of this right triangle, and so the big hypotenuse is 15 and the little hypotenuse is 10. These are corresponding sides. You notice our vertical side right here is 9. It would correspond with the 6. And can you guess what would correspond with the 8? You guessed it, the 12. Okay, so that's what corresponding sides and corresponding angles are. Corresponding angles have to be equal to each other, and corresponding sides need to be proportional. So a real quick lesson here, or a review, is that proportional means that fractions equal fractions. So if I line up all my corresponding sides, I can tell if they're proportional. Notice, these are all my small triangle numbers, 10, 6, 8, 10, 6, 8. These are all my large triangle numbers, 9, 12, 15, 9, 12, 15. Notice that the two hypotenuses correspond, so they are numerator-denominator, and our two shortest sides correspond, and the medium sides correspond. Do they all look like they equaled each other? Proportional means these fractions will equal each other. At the beginning, it doesn't look like it, but what if you simplify them all? You know, divide by 5 here, divide by 3 here, and divide by 4 and divide by 4 here. What would it look like? Now it looks like they are all proportional. And so we know that these two shapes are similar. So the first thing in the book, they ask you just to be able to tell which rectangle is similar to rectangle A. You have two choices, 50-50 guess. But if you take a moment and think about it, that we've got the short side and the long side, and we put all the short numbers up top for the rectangles and all the long numbers in the denominator, we can set up three fractions. Do these fractions equal each other? We can find out. Or better yet, which fraction equals rectangle A? Once again, if you simplify, it makes it look a whole lot easier. Did you notice these were the two that matched? That's why rectangle C is similar to rectangle A. Let's try it with parallelograms. Which one is similar to parallelogram A? Once again, we've got our short sides and our long sides. Short, long. If we line them up, when you simplify, it makes it very apparent that parallelogram B is similar to parallelogram A. Sorry everyone, that's my dog. I think I just spooked him. The next thing you're going to have to do, easy buddy, you're okay. How can I find the missing side? So, do you notice I have a little shape and I have a big shape? We have to set up a proportion here. And so I'm going to have all the little shapes numbers up top in the numerator and all the big shapes numbers down below in the denominator. So my 6 and my 8 will go up top. Which number will correspond with the 6? That's right, the 9. Which side will correspond with the 8? That's right, the x. So when I set up my proportion, I've got it set up like this. Notice my little triangle numbers. The 6 corresponds with the 9 and the 8 corresponds with the x. In order to solve this, we can cross multiply. 6 times x is 6x. 9 times 8 is 72. I divide by 6 and divide by 6. And I get the answer, x equals 12. Any questions? How about if you try this one? I'll let you pause it for a second. Okay, here's a clue. Notice little numbers up top, big numbers down below. Make sure the sides correspond. Did you notice that the 6 corresponded with the 9? Did you notice that the x corresponded with the other 6? And so, I cross multiply. 9x equals 36, divide by 9, and x equals 4. One more. I'll pause here in case you want to take a look at it. Cross multiply, divide by 7, and you get the answer. Now there is a little bit of a shortcut here if you recognize the pattern. Do you notice that this says 7 centimeters and this says 14? 7 times 2 would be 14, and you could have just multiplied 12 times 2, which would have guessed it, 24. How can we mess with you? Well, I don't have to have the shapes in the exact same position when I shrink them. In this situation, I rotated it 180 degrees. Now, did you recognize that the 5 and the 7 are from this shape? And which number corresponded with the 5? It was the 11. Which number corresponded with the 7? It was the x. When you cross multiply, 5x equals 77, divide by 5, and I get my answer, 15.4. Notice not every answer has to end up being a perfect number. Decimals can be answers here. All right, now here's an interesting one. If I believe it's problem number 17 in your book. If I'm standing next to a flagpole, I can use these similar triangles for all kinds of fun stuff. I can measure things that aren't easily measured. The thing that I can measure is a flagpole. I mean, other than taking it down, putting it on the ground, and then measuring it, or getting a really tall ladder and then trying to measure it and risking injury, there's another way you can do it just simply by using math. Watch this. Do you notice that I have two similar triangles? One, if I have the sun coming here, the flagpole will be creating a shadow. If I line the top of my head up with that exact same shadow, I have two similar triangles. If I'm 5 feet tall and I cast a 3-foot shadow and I measure the shadow length of the flagpole, say 36 feet, I can figure out how tall this flagpole is. I set up a proportion. Notice, I have 3 and 5, that's me. This is my shadow number. This is my actual height. The shadow for the flagpole is 36, and I don't know what its height is, so that's how I figure it out. Cross multiply, divide, and I know that this flagpole is 60 feet high. Also, what happens if I want to do this one? I want to measure across a river without actually having to cross the river. I want to build this bridge. I can use similar triangles to figure out how wide the river is. Notice, I don't know how wide this river is, but everything else can be measured from this side of the room, or this side of the river. If this was 45 meters, this was 18 meters, and I walked backwards 16 meters, I could look in a straight line across the river and notice that I could figure out this. Set up the proportion, cross multiply, divide, and I get my answer. All right, well that's similar shapes. They can be used for lots of things. We'll be visiting these again next chapter. So this is kind of like a precursor. If you got any questions, please feel free to give me a call. Everyone have a great day. Bye.